Did you ever struggle to help your kids understand how to do multiplication? Do you find yourself getting frustrated when you're trying to teach them how to do multiplication the way that you know how to do it and they're just not getting it? That's what I'm here for. My name's Jeff Dean and I'm Math Dad. I'm here to help you help your kids understand math. The curse of knowledge is a real thing. Anytime you struggle to remember what it's like to be a learner, to be at the very beginning of something that you've become an expert at, you may struggle from the curse of knowledge. Have you ever tried to teach how to drive? Slow down. Well, get up to speed. Why did you take that turn so quick? Look over your shoulder. Why are you swerving the car when you're looking over your shoulder? Stop. Go. It's a struggle because we don't remember what it was like to be a new driver. The same thing happens when we try to teach our kids how to do math the way that we know how to do it if we're talking at a level that's more advanced than how they think about it or how they understand it. It's time to take a step back and see some other ways that we can help our kids understand how to make sense out of multiplication. Let's take a look at a multi-digit multiplication problem, the way that you and I probably learned how to do multiplication. We start with 6 times 3, which is 18. So we put the 8 down here and we carry the 1. 3 times 4 is 12, plus the 1 we carried, gives us 13. So we carry the 1 again. 3 times 1 is 3, plus the 1 we carried is 4. And now here's the key to this method. Because we're moving to the next column, we put a placeholder right there. Whoa, 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 whoa. Hold up. We do what? We put a placeholder? What the heck does that 0 even mean? Here's an opportunity for you to check for understanding. If your student or you don't really know why we put that 0 there, chances are all we've done is memorized a process and we really don't have mathematical understanding. The reason why that 0 is there is because we're now multiplying by 2, which is in the tens place. So it's actually multiplying by 20. 2 times 6, it's actually 20 times 6, which is 120. So there's the 20, and when we carry the 1, that's our 120. That's the reason why that 0 is placed there. Let's keep going. 2 times 4 is 8, plus the 1 we carried gives us 9. And finally, 2 times 1 is 2, and we add everything together, and we end up with 3,358. That is the standard algorithm for multiplying multi-digit numbers. And it's probably how you and I remember doing multiplication. When you're working with your students, if you're finding that they're struggling with this process, or they don't know what the 0 represents, or they don't understand what all of these 1s up here are, or they don't understand why you're adding everything together, chances are they're not ready to perform multiplication in this compact way. They might need to take a step back and break things down a little bit so they can see exactly what's happening in this standard algorithm. What we're going to do in this method is we're going to break this down a little bit more, so hopefully students will start to gain an understanding for what's happening over here. So instead of writing 146 as a single number, we're going to look at 140 and 6 as separate numbers. We could put a plus sign inside so we can still see that it's still 146. And then we're going to take 23 and do the exact same thing. We're going to write 20 and we're going to write 3. when we multiply, we're going to follow the same procedure that we did for the standard algorithm, but we're going to write everything down. For example, 3 times 6 is 18. We're just going to write 18. 3 times 40 is 120. And 3 times 100 is 300. And you can see here, here's our 4, there's our 3, and there's our 8. We're just breaking this down a little bit more for our learners. Then when we move to the 20, there's no longer this placeholder. They start to see where it comes from. 20 times 6 is 120. That's the placeholder. 20 times 40 is 800. That's the placeholder. 20 times 100 is 2,000. There's the placeholder. Then when we add everything up, we have 8, we have our 5, we have our 13, and our 3. 3,358. But we can see how these three numbers make up this, and these three numbers make up this. And we can see even why we put a placeholder, because all three of those numbers end up having a 0 in that place. For students who this still isn't making sense, we may need to still step back another notch and break it down even more so that they can start to make more sense out of what's going on here. Let's look at the next strategy. Many times when students struggle with this process, it's because they struggle understanding how they're supposed to multiply the numbers together. For example, to go 3 times 6, and then 3 times 40, and then 3 times 100, and then move to the 20, 20 times 6, 20 times 40, 20 times 100, it's a lot to keep track of. We give them something to help organize our work, and this is called an area model. We take our 100, 40, and 6 and we put it across the top. And we take our 20 and 3 and we put it along the side. And again, we can continue to put our plus signs in here if we want to make sure that we see we still have 146 and 23. Now what I'm going to do is this. I'm going to draw a couple of vertical lines and a horizontal line. And what I'm attempting to make is something that looks like a multiplication chart, because just about every student who's ever learned multiplication has at one time seen a multiplication chart, and they understand how it works. We take our 6 and our 3 and we multiply them together, and we get our answer. We put it in that box. We take our 3 and our 40 and we put them here. And we take our 103 and we put them right here. Now, when we move to the 20, we can see that, oh, we have to fill in this row also. So 20 times 6 is 120. 20 times 40 is 800. And 20 times 100 is 2,000. The reason why this is called the area model is because when we add up all of these numbers, we actually have the area of the rectangle. This is just a graphic organizer to help make sense of this process. And this process is just a little bit drawn out to help make sense out of the standard algorithm. When our students aren't quite ready to multiply numbers together this quickly, the next step we can take them back to is breaking everything down into tens and hundreds and ones. So we can take this idea and break it down even further. What we're going to do is take advantage of the fact that most students know how to multiply by 10 or multiply by 100. So instead of writing 23, I'm going to write 10, 10, and 3. And instead of writing 140 and 6, I would write 100, 10, 10, 10, 10, and 6. I'm going to draw the same vertical lines and same horizontal lines as before. And you can see, yes, I have a lot more to multiply, but the idea is to make the connection to the strategy that's one step more efficient. Because we don't want to do this every single time. We want to eventually get this student to this strategy. So 10 times 100, 1,000. 10 times 10, 100, 100, 100, 100. And 10 times 6 is 60. And now 10 times 100 is 1,000. 10 times 10, 100, 100, 100, 100. 10 times 6, 60. 3 times 100, 300. 3 times 10 is 30. 30, 30, 30, and 18. Now, I know that there's a lot more to do here, and there's a lot more to add, and there's a lot more to multiply. But what we're trying to do is help them see, see right here, 1,000 and 1,000, that's 2,000. How many hundreds do we have? 1, 2, 3, 4, 5, 6, 7, 8. 8 hundreds. We have a 300 right here, and we have 30, 60, 90, 120, and here we have 60, 120, and our 18. So when we add all of that together, we still have 3,358. But the idea is to make the connections between this process and this one, which was one step more efficient. When we struggle to help our students understand a math concept, it is so important that we learn as adults what are ways that we can break down the process so that we can make connections to more and more efficient methods. But if we suffer from the curse of knowledge, then we might get really frustrated because we won't remember what it's like to learn this for the first time. Our goal is not to create a lot of work for our kids, but to start with a process like this so that they can connect it to the next most efficient process. And then once we have that down, we connect that to the next most efficient process, because ultimately our goal is to help them see how they can put all of this together and understand and use the standard algorithm. That is true mathematical understanding. When we see the connections, we can apply what we've learned, and then we can compress them into ways to be very efficient. But if we're really honest with ourselves, really honest with ourselves, then we will see that the true understanding comes from the less efficient strategies. This is great to get an answer, but true understanding of mathematics is when you can break it down and show what's really going on. My name's Jeff Dean, and I'm Math Dad.